Good morning. Uh, I think we have done 21st and then 23rd. So today we'll be starting with sum number 22 from miscellaneous exercise. This is an important sum. Show that 9 pi upon 8 minus 9 by 4 sine inverse 1 upon 3 equal to 9 by 4 sine inverse 2 root 2 by 3. To prove this means to prove what? See what I have done. I have multiplied both sides by 4 by 9 and I have shifted this term to RHS. So we have to prove what? Sine inverse 1 by 3 plus sine inverse 2 root 2 by 3 equal to. Now if you multiply 9 pi by 8 by 4 by 9, what remains is pi by 2. Now next part is simple. See, sine inverse x plus cos inverse x is pi by 2. So it is sufficient to prove that sine inverse 2 root 2 upon 3 is nothing but cos inverse 1 by 3. Let sine inverse 2 root 2 upon 3 be alpha. Now ratio is positive, so alpha lies in first quadrant. So cosine ratio is also positive. Now you can use fundamental identity or construct the triangle. What is sine? Opposite side upon hypotenuse. So by corollary of Pythagoras theorem, adjacent side is 1. So it is cos alpha. Adjacent upon hypotenuse, that is 1 by 3. So alpha is cos inverse 1 by 3. Therefore, sine inverse 1 by 3 plus sine inverse 2 root 2 by 3 is what? Sine inverse 1 by 3 plus cos inverse 1 by 3, which is nothing but pi by 2. 24th is simple one. If sine of sine inverse 1 by 5 plus cos inverse x is 1, find the value of x. Now invert the relation. So sine inverse 1 by 5 plus cos inverse x is sine inverse 1, which is pi by 2. Or you may say replace this 1 by sine pi by 2 so that this becomes pi by 2. Same thing. But we know that sine inverse of x plus cos inverse of x is pi by 2. So x has to be 1 by 5. 25th, let me explain. You have to write the solution after the lecture. If tan inverse x minus 1 upon x minus 2 plus tan inverse x plus 1 upon x plus 2 is pi by 4, find the value of x. Now use tan inverse p plus tan inverse q formula. It is tan inverse p plus q upon 1 minus pq. Now multiply numerator and denominator by x minus 2 into x plus 2, right? So this is nothing but tan pi by 4 because the relation is inverted. Okay. Now x plus 2 into x minus 1 plus x plus 1 into x minus 2 upon what? X minus 2 x plus 2 minus x minus 1 x plus 1. Simplify, obtain equation. That equation is 2x square equal to 1. So x square equal to half. So x equal to plus minus 1 by root 2. So this is the answer. 26th, if 2 tan inverse cos x equal to tan inverse 2 cosec x, then find the value of x. Now what is 2 tan inverse cos x? Actually it is tan inverse cos x plus tan inverse cos x. What is tan inverse p plus tan inverse q? Tan inverse p plus q. Cos plus cos 2 cos upon 1 minus pq, that is 1 minus cos square, equal to this. So that gives me 2 cos x upon 1 minus cos square x equal to 2 cosec x, that is 2 upon sin x. Now 1 minus cos square is sin square. As cosec is defined, sin is definitely not equal to 0. So I can cancel sin x to get sin x equal to cos x. So x is nothing but pi by 4. 27th, solve the equation. Tan inverse 1 minus x upon 1 plus x is half tan inverse x where x is greater than 0. Now multiply both sides by 2. What is 2 times this? Tan inverse plus tan inverse. So 2 times tan inverse. But tan inverse p plus tan inverse q is tan inverse p plus q upon 1 minus pq. Here p is same as q. Now simplify. So basically tan inverse P is tan inverse Q. So I have directly written P equal to Q. See, I have multiplied numerator and denominator by 1 plus x bracket square. And that is why I have written 2 times 1 minus x into 1 plus x. What about denominator? 1 plus x bracket square minus 1 minus x bracket square equal to x. Simplify, open all the brackets, cross multiply, you get which equation? 4x square equal to 2 minus 2x square, that is 6x square equal to 2. So x square equal to 1 by 3. You may say x equal to plus minus 1 by root 3. No, the only answer is x equal to 1 by root 3 because x is given to be greater than 0. Sum number 28. If sine inverse 1 minus x minus 2 sine inverse x is pi by 2, find the value of x. Now sine inverse 1 minus x minus 2 sine inverse x is pi by 2. So sine inverse 1 minus x is pi by 2 plus 2 sine inverse x. Invert the relation. So 1 minus x is what? Sine of pi by 2 plus 2 sine inverse x. Now sine of 90 plus theta is cos theta. This is an important step. So 1 minus x is cos of 2 sine inverse x. Now the next part is important. Can you tell me formula for cos 2 theta? Cos 2 theta is 1 minus 2 sine square theta. So what is cos of 2 sine inverse x? It is 1 minus 2 times square of what? Sine of sine inverse x. I'll explain this part again. See, consider sine inverse x as theta. What is cos 2 theta? 1 minus 2 sine square theta. So cos of 2 sine inverse x is 1 minus 2 square of what? Sine theta. So sine, but what is theta? Sine inverse x. Now what is the advantage of this? Sine of sine inverse x is simply x. So equation becomes 1 minus x equal to 1 minus 2x square. That is 2x square minus x equal to 0. Now many students have tendency to cancel x. Do not cancel x in this step because x can be 0. We can rule out that possibility later on, but initially you have to consider both the values. So x is equal to 0 or x equal to half. Now when x is half, left hand side becomes sine inverse of half minus 2 sine inverse of half. Is it pi by 2? No, it is minus pi by 6. So we cannot consider x equal to half. So what is the value of x? It is nothing but 0. Now you may say, why 0? You can verify this. See, put x equal to 0. Sine inverse 1, which is pi by 2, minus sine inverse 0, which is 0. Yes, pi by 2 is same as pi by 2. Is that clear? So initially we got two values, half and 0. We discard half, and what is the final answer? X equal to 0. 29th, if tan inverse 2x plus tan inverse 3x is pi by 4, then find the value of x. Okay. Tan inverse p plus tan inverse q is tan inverse p plus q upon 1 minus pq. In the same step, I have inverted the relation. So 5x upon 1 minus 6x square is tan pi by 4, which is 1. So 5x equal to what? 1 minus 6x square. You get a quadratic equation, 6x square plus 5x minus 1 equal to 0. Two roots are minus 1 and 1 by 6. But if you put x equal to 1, tan inverse of minus 2 plus tan inverse of minus 3 cannot be pi by 4. So we discard that and we consider x equal to 1 by 6. 30th for homework, it is simple one. Begin with LHS, tan inverse half minus tan inverse 1 by 4. In fact, you can do this orally. Tan inverse P minus tan inverse Q is tan inverse P minus Q upon 1 plus PQ. That's it. Now we'll be doing sum number 31. Show that cot inverse 1 by 3 minus tan inverse 1 by 3 is cot inverse 3 by 4. 31st one, show that cot inverse 1 by 3 minus tan inverse 1 by 3 cot inverse 3 by 4. Begin with LHS. It is better if you mention this. What is cot inverse x? Tan inverse 1 upon x. So this is tan inverse 3 minus tan inverse 1 by 3. Apply tan inverse p minus tan inverse q formula. I have multiplied each term by 3. So tan inverse 9 minus 1 upon 3 plus 3. So tan inverse 8 by 6, that is tan inverse 4 by 3. But tan inverse 4 by 3 is cot inverse 3 by 4. It is better if you mention this, that tan inverse P is cot inverse 1 upon P. 32nd, show that tan inverse half is 1 by 3 tan inverse 11 by 2. That is to prove, multiply throughout by 3. That is to prove 3 tan inverse half equal to tan inverse 11 by 2. Now, 3 tan inverse half is tan inverse half plus tan inverse half plus tan inverse half. Now, for this, use tan inverse P plus tan inverse Q. That gives me tan inverse 4 by 3 plus tan inverse half. Again same, tan inverse P plus tan inverse Q is tan inverse P plus Q upon 1 minus PQ. Simplify to get tan inverse 11 by 2, which is nothing but right hand side. 33rd is for homework. This is again a simple one. What is cos inverse root 3 by 2? Pi by 6. What is sine inverse root 3 by 2? Pi by 3. Add them to get pi by 6. 34th, show that 2 cot inverse 3 by 2 plus sec inverse 13 by 12 is pi by 2. Now, what is 2 cot inverse 3 by 2? It is 2 tan inverse 2 by 3, which is tan inverse 2 times 2 by 3 upon 1 minus 2 by 3 into 2 by 3. I hope you won't ask why this. Tan inverse 2 times tan inverse 2 by 3 is tan inverse 2 by 3 plus tan inverse 2 by 3. And then apply tan inverse P plus tan inverse Q formula. So this is now tan inverse 12 by 5. Let it be alpha. So tan alpha is 12 by 5. Now construct the triangle. This is the simplest method. Tan is opposite upon adjacent. So that gives hypotenuse as 13. Now from this, what is cosec? It is hypotenuse upon opposite. Invert the relation. So alpha is cosec inverse 13 by 12. But we have put alpha for tan inverse 12 by 5, which is basically 2 cot inverse 3 by 2. And that is why I have written 2 cot inverse 3 by 2 equal to cosec inverse 13 by 12. Now what is LHS? 2 cot inverse 3 by 2 plus sec inverse 13 by 12. So this becomes cosec inverse 13 by 12 plus sec inverse 13 by 12, which is nothing but pi by 2, which is RHS. This is standard result. You can mention that cosec inverse x plus sec inverse x is pi by 2. 35th, now there is correction in the textbook. I think first sum is not given correctly. It should be cos inverse x equal to tan inverse root 1 minus x square upon x. Okay. Second is correct, I think. Now this is simple one. Let cos inverse x be alpha. So cos alpha equal to x. Now x is greater than 0. So clearly alpha lies in first quadrant. So sine and cos are positive. Now tan inverse root 1 minus x square upon x is what? Tan inverse sine alpha upon cos alpha, that is tan alpha. But alpha is cos inverse x. And therefore cos inverse x is nothing but tan inverse root 1 minus x square upon x. It's a simple one. Second part, let cos inverse x be alpha. Same logic. So tan inverse root 1 minus x square upon x becomes tan inverse tan alpha. Now alpha lies in which quadrant? Second quadrant. Why? Because they say x is negative, x is less than 0, right? So cosine ratio has to be negative. So angle lies in second quadrant. Let me explain this. But pi by 2 less than alpha less than pi, inverse of tangent does not exist. Why? Because for that it has to lie between minus pi by 2 and pi by 2. This step is important. See, and therefore subtract pi. If you subtract pi, you get minus pi by 2, alpha minus pi less than 0. And tan of alpha minus pi is nothing but tan of minus in bracket pi minus alpha, tan of minus theta is minus tan theta. But already minus is there, so it is plus. So from 1, we get tan inverse root 1 minus x square upon x equal to tan inverse of tan alpha minus pi, which is simply alpha minus pi. That is cos inverse x minus pi. 36th, if mod x is less than 1, then prove that 2 tan inverse x is tan inverse 2x upon 1 minus x square equal to sin inverse 2x upon 1 plus x square equal to cos inverse 1 minus x square upon 1 plus x square. We begin with let tan inverse x be y. So x is tan y. Now what is tan inverse 2x upon 1 minus x square? It becomes tan inverse 2 tan y upon 1 minus tan square y. But this is formula for tan 2y. Tan inverse of tan 2y is 2y. But y is tan inverse x. So this proves that tan inverse 2x upon 1 minus x square is what? 2 tan inverse x. Suppose this is number 1. Okay. Now same for sine inverse 2x upon 1 plus x square. We get sine inverse sine 2y, that is 2y. So again it is 2 tan inverse x. Basically the formula is expression of sine 2 theta, cos 2 theta, tan 2 theta in terms of tan. And cos inverse, right, 1 minus x square upon 1 plus x square, this becomes cos inverse 1 minus tan square y upon 1 plus tan square y equal to cos inverse of cos 2y equal to 2y, that is 2 tan inverse x. This is third result. Therefore, from 1, 2 and 3, write down. Please do not write in this fashion. You have to say from 1, 2 and 3. 2 tan inverse x is tan inverse 2x upon 1 minus x square, is sin inverse 2x upon 1 plus x square, is cos inverse 1 minus x square upon 1 plus x square. Sum number 37, this is simple one. If x, y, z are positive, then prove that tan inverse x minus y upon 1 plus xy plus tan inverse y minus z upon 1 plus yz plus tan inverse z minus x upon 1 plus zx equal to 0. This is playgroup sum. Use tan inverse p minus q upon 1 plus pq as tan inverse p minus tan inverse q. So you will notice that all the terms get cancelled. So what remains is 0, which is right hand side. 38 sum should be like this. There is correction. It goes like, if tan inverse x plus tan inverse y plus tan inverse z is pi by 2, then show that xy plus yz plus zx equal to 1. Now you may say we will apply this result and then again tan inverse p plus tan inverse this equal to. That is also correct. But why to apply this 2 times? See, tan inverse x plus y upon 1 minus xy becomes pi by 2 minus tan inverse z. Invert the relation. So x plus y upon 1 minus xy becomes tan of 90 minus theta, which is cot theta. Now what is tan inverse z? Cot inverse 1 upon z. Cot inverse 1 upon z is 1 upon z. So we get x plus y upon 1 minus xy equal to 1 upon z. Cross multiply, zx plus yz equal to 1 minus xy. Rearrange the terms to get xy plus yz plus zx equal to 1. 39th, again there is correction. If cos inverse x plus cos inverse y plus cos inverse z equal to 3 pi, then show that x square plus y square plus z square plus 2xyz is 1. Now this is interesting. See, for cos inverse x, what is the range? 0 to pi. So the minimum value of cos inverse x equal to 0 and maximum is pi. Now we are given that cos inverse x plus cos inverse y plus cos inverse z is 3 pi. Now the maximum value of each is pi, and therefore it is clear that each in this case is pi. See, if you say it is less than pi, then any one of these will have value greater than pi, which is absurd. And therefore cos inverse x equal to cos inverse y equal to cos inverse z equal to pi. Then only their addition can be 3 pi. So x is y z is cos pi, which is minus 1. Substitute the values, simplify to get value as 1, same as right hand side. So that's it for today. In fact, we have completed the topic trigonometric functions. In the next lecture, we'll be starting with new topic.